Hi students, welcome to our channel Physics to Learn. In last class we have been discussed regarding the gravitation introduction part as 1. So in this class we are going to discuss regarding the concept of Kepler's laws. So regarding gravitation, so Kepler's laws, so which you have been taken, we can take it as a 3 types: Kepler's first law, Kepler's second law and Kepler's third law. Kepler's first law of planetary motion, regarding motion of objects which we are discussing around the sun. So Kepler's laws, it has been explained by Kepler, so based on that scientist names which they have been given. Kepler's first law, also we can call it as law of orbits. Kepler's second law, also we can call it as law of areas, and Kepler's third law or law of periods, so which we can call it. Kepler's law of planetary motion. Before we study Kepler's laws, let us understand some concept of ellipse. So in mathematics we have been studied regarding ellipse. So ellipse will be having 2 axes. One we can call it as major axis, one more we can call it as minor axis. So Kepler's first law or laws of orbit, how we can tell in terms of definition form. Each and every planet moves around the sun in an elliptical orbit with the sun at one of the foci. So just here you can observe from the figure, you can observe that, so which I have been taken here as Earth is at one of its foci, sun, and then Earth is revolving around the sun in an elliptical orbit. So for this ellipse which you have been taken, sun at one of the foci and Earth, these two are separated by a small distance r. F1 is a foci and F2 is also foci. Distance of the Earth from the center of the sun. So AO we can call it as semi-major axis and OC we can call it as semi-minor axis. So perihelion or perigee means perihelion we can tell it as the distance of closest approach of the planet with the sun as PS, which you can see in the diagram, is called perihelion. So epicycles or apogee means from the figure we can understand that distance from S to A, the greatest distance AS of the planet from the sun is called epicycles. So related to this you can see MCQs. First law of Kepler's is also called as, so please pause the video and try to write the answer in comment. The first law of Kepler's is also called as, which is nothing but law of orbits. Every planet revolves around the sun in an elliptical orbit with the sun at one of its foci. It is stated as, you can see the options, pause the hold and then you can comment the answer in video. Law of period, law of orbit, law of area and law of gravitation. So which is nothing but law of orbit. So regarding Kepler's second law of planetary motion. So what this Kepler's second law it will tells. So consider a radius vector from the sun to the earth. Here S is the sun and this is a planet, so which you can consider. In general we are taking it as a semi-major axis, so which we can be considered. So that planets which it has been moved from one place to another place. Suppose the planet travels for some distance in a finite time, that means at fixed time, so which we can find it. So in this finite time it covers an area of A1 with respect to the sun. That area which we can represent it as A1. Similarly, after some time in the same time period which it can covers some area A2 with respect to the sun. That area covered which we can take it as, so which is nothing but A2. So from the figure we can understand this, in same time period it can cover some area as a A1 and then here it can cover some area as A2. So from this Kepler's second law of planetary motion, we can tell it as sweeps out equal areas in equal intervals of time. So based on that, so which we can tell it. Since the time taken by the planet is same, their area covered is also same. So with that we can conclude that A1 which is equals to A2, the area covered by second time. With this we can tell the definition as Kepler's second law as like this. The radius vector drawn from the sun to any planet sweeps out equal areas in equal intervals of time. So this Kepler's second law is also known as law of areas. So the law of areas can be understood as consequence of law of conservation of angular momentum. Regarding this angular momentum, we have been discussed in system of particles as L is equals to I omega, or I is nothing but moment of inertia. I is equals to mr square. With that concept, now we are going to prove it as sweeps out equal areas in equal interval of time. So this law of conservation of angular momentum is valid for central forces. So what is the meaning of central force? Central force is that force on a planet which is along the vector joining the sun and the planet. So between sun and planet, so which we are considering. So a proof of law of areas are Kepler's second law. A planet moves in an elliptical orbit from position A to position B in a time delta t. So this is the initial position, so which I can take it as theta. Then after some time its angular displacement is delta theta. So in order to move from A to B, which it can cover some distance, that is nothing but r into d theta. Here you have been seeing this area, so which will be in the form of a triangular shape. Now I have to find out this area. Area of triangle is nothing but half into base into height. With the help of that, what I am going to prove, the area swept by position vector r is equals to the area of triangular region. This is a triangular region, so which I am going to take. For that, area of triangle is nothing but half into base into height. That half into, here base I can take it as r, into height which I can take it as r into d theta. So r into r is nothing but r square, so which I can write. So as if we know that, we should have to prove it as sweeps out equal areas in equal intervals of time. That means differentiating both sides with respect to time. That delta A by delta t is equals to half into r square into d theta by dt. If you have been seeing this, which you have been learned as angular velocity is nothing but the rate of change of angular displacement. delta theta by delta t, we can write it as omega. So with this also we can use it as, in calculation purpose, delta A by delta t is equals to half into r square into omega, which we can be used. But we should have to write in terms of angular momentum. That angular momentum of planet of mass m is, I can write it as L is equals to m into r square omega, where mr square is nothing but moment of inertia. By substituting this as omega, L by mr square, so in the above equation, so what we have been discussed, dA by dt is equals to half r square omega. With this, so we can obtain it as r square, it will be gets cancelled. We can prove it as finally delta A by delta t is equals to L by 2m, which we can write. And then in system of particles, we have been proved that law of conservation of angular momentum. That means angular momentum L is a constant. The aerial velocity of the planet is constant. That means if you have been taken specific time period, it covers equal areas. So based on that only, which we can tell it as sweeps out equal areas in equal intervals of time. So this you have been studied as one more angular momentum. We can write it as mvr. M represents mass, v represents velocity, r represents radius, position vector, which we can take it. Here they have been taken it as vp represents velocity at perihelion, rp represents radius of perihelion, va is a velocity at epicycles, ra represents radius at epicycles. Based on that, here m is a constant, so we can tell it as v is inversely proportional to r. So with that, if ra is greater than rp, then it will be inversely proportional va is less than vp, so which we can tell it. Why? So it is the speed of earth more at perihelion than at epicycles, so which we can find out. The speed of earth at the perihelion is more than that at epicycles. So you can see, for this clarification, you can see this diagram Nana. So what you have been discussed, so this is a epicycles and this is a perihelion. At this point velocity is va, at this point velocity is vp. So here it can covers less, it can travels with less speed, but whereas here it can travels with more speed. So based on this MCQ, which you can go through once. So stop the video and read the question and then comment the answer below. Which law states that the line joining the sun and the earth sweeps out equal areas in equal intervals of time? So that which is nothing but Kepler's second law. So you have been discussed already the definition, sweeps out equal areas in equal intervals of time. So the motion of planet in solar system is an example of conservation of dash, mass, linear momentum, angular momentum and energy. So which is nothing but in rotatory motion, so we can discuss it as in simple form, which is nothing but angular momentum. So which you have been discussed. So regarding Kepler's third law. So for this Kepler's third law proof also, which we can discuss in further classes. Now we are going to discuss what Kepler's third law it will tells. You can see the definition. The square of time for a planet to complete one revolution around the sun square, which they have been given, is directly proportional to cube of semi-major axis of the elliptical orbit. So semi-major axis, semi-minor axis, so which we have been discussed. Based on that, which we can tell it as this will be the sun, this will be the planet. In order to complete one revolution, you can see in imagination, in image which I am showing, so as which it can complete one revolution under that condition. So what it will happen, that radius is r and square which they have been given, square of time period is directly proportional to cube of a semi-major axis. So t square is directly proportional to r to the power of 3, so which we can tell it. With this we can tell it as t square by r cube is equals to constant. Regarding this proof also, which we are going to discuss in further classes, where r is a semi-major axis of elliptical orbit. So the same thing which I am going to explain, so to understand you clearly. So based on this, what we can take, let t be the time taken by the planet to complete one revolution, so which we can see that, let r be the semi-major axis of this ellipse, r which have been taken it as this. So here I should have taken it as Kepler, so that t square is directly proportional to r to the power of 3. So t square by r cube is nothing but constant, so which we can tell it. So with this, the definitions which I have been tell it as the square of period of revolution of the planet around the sun, t square, is directly proportional to cube of semi-major axis of the elliptical orbit, which is nothing but r cube, so which I have been taken. So this Kepler's third law is also known as harmonic law or law of periods, so which we can call it. So regarding third law, which you can see the MCQs, according to third law of Kepler's, t square is directly proportional to r square, t square is directly proportional to r cube, t square is directly proportional to r, t is directly proportional to r. So please stop the video and then write the answer, comment below. So our answer is t square is directly proportional to r to the power of 3. So what we have been said from the definition, so which we can tell it. According to Kepler's, a satellite always revolves in an circular orbit, elliptical orbit, parabolic orbit. So answer is elliptical orbit. So thank you. Please like the video and share to your friends.